Hello everyone, my name is Anton, and today I made a short video about TI Instruments NPU. And this will be a little unusual video. Usually I look at each board as on a piece of hardware. Describe a comprehensive picture, like how easy to set up it, how to use, how to run neural networks, what are the problems with these neural networks. But today everything will be a little different. I will be focused on the last part. I have long wanted to test a TI Instruments board, but I was too thrifty to spend $100 on a board that I will almost certainly not use anywhere. And this will be in the final part of the video. It's not the bad boards, it's just boards for production. Among these boards, of course, there are BeagleBone, which can be used somehow on like hobby projects, but mostly it's production boards. And there are a lot of TI Instruments boards today. For example, you can check some boards from Toradex, TQ Group, also ZLG, also a lot of companies like VVDN or other companies, they are building their software with like TI Instruments. But in my opinion, like the main part for such boards, of course, it's production. And when I was thinking how to run some tests on these boards, suddenly I was advised to look at TI Instruments website, where you just can test any of them their AI boards for free. Here it is. You just make a request and they open 3-hour session of access to the board for you through Jupyter Notebook. Of those boards, I tested 2, the rest, this one, and the rest just don't start. Maybe there is a queue, maybe they're not available right now, I don't know. And here I will immediately say a small disclaimer. If you will ask the Jupyter Notebook what kind of system installed here, it will tell you that it's a system based on Intel, which is funny. At the same time, the test results report that it's like TI Instruments board, IM68A. Could it be an emulator? In theory, yes, but also it can be some complex like setup with few boards where like one is for Jupyter Notebook and the second is the real where all the tests are inferred. But I don't understand how it's connected because I can see any devices like on USB or PCI Express bus. So it's like a little bit tricky to do all speed tests here. So and in my opinion, it's pretty important that even if it's an emulator, it looks like the real board. And it's allow me to check like how to run everything, what are the pipelines, is it like really working, how to run everything, and so on. And I would like to start with pros of TI Instruments boards and a lot of interesting comparison points and insight that I get when I was running all this stuff. First of all, it's super cool when you have like a server where everything is set up and working. You can test everything before you buy in. You can test everything, like have this setup as your test setup. It's pretty nice and pretty interesting. Of course, like I mentioned that I think it was from STM32, they have a similar service to benchmark models. And in my opinion, it's super important when vendors provide such service where you can check how the board is working, check different conditions, and so on. So 2 thumbs up. The second pros is they using reading like TF Lite runtime and ONNX runtime for inference, and it's like divine. Yes, a similar scheme is used for NXP and MediaTek boards. Watch my previous videos about them. But for example, there was no support of ONNX runtime platform. All this support was a little bit tricky. And here, like, it's you just use your existing environment with additional libraries that will specify your inference NPU chip. And when it's like the main focus of the vendor, in my opinion, it's super cool. You don't need to think about each new vendor from how you will prepare everything, how they create internal infrastructure, and so on. Like supporting ONNX runtime and TF Lite is super cool, especially ONNX runtime, because today, like TensorFlow, it's already like pretty old framework that it's not used. And in my opinion, like ONNX first, it's of course how you should create your new boards. And it's the first board when I meet this approach, like ONNX inference first. Super cool. And the third point, it's also with this, it's about expert. Do you know one of the problem with ONNX? One of the problem with ONNX, it's a little bit hard and complex to create int8 quantized model in ONNX, which you can use on the separate device. Anti-Hash instruments solve this problem. They created a different library which you can use through ONNX runtime to quantize your model. And this, in my opinion, it's super cool solution which other vendors should utilize, because previously, like, the main idea why a lot of people use TF Lite was because TF Lite support int8 quantization out of the box, like without any blows and whistles, and it's cool. But with ONNX runtime, it's the first solution where this problem is solved. And the fourth plus, a lot of models are supported, and which is super important, MM series model, MMCV models, they are supported. Not all of them, but like MM detection, for example. And it's super cool because for a lot of companies, as far as I know, like all this MM infrastructure, it's primarily infrastructure. And usually, specifically this MM detection and stuff like this, they are required a lot of work to export them even for Jetson, because they have their own export scripts and so on. And here, when THAS instruments like solve this problem of export, I tested a few models and they are working. In my opinion, it's super cool. But not everything so good, sadly. And let's go to some cons. First of all, too many repositories, too much code, too little documentation, very confusing documentation. Here is one approach to export, here is another. There is no clear criterion for when to use what one of them. And it's a little bit confusing because you need some straightforward approaches, but here you need like to research a lot about how to run all this stuff. In general, all repositories have 100 stars on average. And this means that they are not very often used, and most of errors are not catched. Like when you have like Rockchip repositories, there is 1,000 stars, and people like communicate, discuss something, and of course, every time there will be a lot of mistakes and errors. But during this discussion process, usually all pipelines became simpler, more people start using it, and it became more straightforward. But here it's like a little bit lack of documentation, lack of usage, and of course, like, it's not very well made product in general, just because of these tests from the real users. Expert simply doesn't work out of the box. It's not that it doesn't work at all, like it was for MediaTek in one of my previous videos, for example. But you can figure out a lot of problems. For the one approach, some libraries were not installed. For other approach, it's required to prepare ImageNet dataset in some strange format, and it was like a little bit complex expert. I spent a total like 4 or 5 hours trying to run all this stuff. I fixed some installation errors, but it's still like there was still some mysterious errors. So in general, I think all of them are fixable. Maybe I'm doing something wrong. Maybe like it's required to do, like, for example, I run this export through Docker. Maybe I need to install everything like on the system and then try to run everything, because there was some strange situation with libraries. But again, we go to the first point in all this documentation. It's not like internal and complex. You need to compose your approach from a lot of small chapters where each one like doesn't correlate very good with the other part. So I'm sure that it's possible to run all this stuff, but it will require some time. And definitely it's not the time you want to spend like if it's your hobby project. But thanks to the servers from TI, you can export pretty easily. Just send your network on this server, export it with already pre-built system, and use it. It makes life really easy. But one of the problems that still exist, it's unsupported layers. And like unsupported architectures, I tried with a lot of neural networks like from my archive, and most of them just didn't work. There was like problems during the quantization, problems during run, and unfortunately debugging, it's a little bit complex because Jupyter Notebook just fell with some kernel error and reboot itself. So there was some logs, but they were required like a little deeper look into them. I didn't find some mistakes in these logs. Sometimes it's just stop working. But for each one class of neural networks, like classification, detection, segmentation, you have at least one fully supported network, which you can take from the examples. And actually, it's really good. So you will have problems when you will go to some uncommon neural networks. For example, like I had a video about 3D networks, 3D reconstruction, and it's like they didn't work almost for all platforms. But it's like the common situation that some complex network don't work. And here it's like the same. But there are some networks that are working and they are fully supported. In general, it's okay. So let's wrap up and sum up my impression of the TI Instruments platform. First of all, formally on documents, in the code, there is a lot of cool stuff, like non-trivial functions, ONNX-Runtime support, and it's really like the general idea is really looking great. And like all the infrastructure around, really, it's like if I didn't test it myself and just read documentation, I would be impressed. But in reality, it like doesn't work as expected. So it works somehow, but no, it will require you a lot of time and efforts to set this up. Not like months, but at least you need to put a few days or week to run your specific task on this platform. So I would not use TIHAS instruments for hobby projects. Why to use it when you have rock chips with a lot of networks and a lot of documentation and a lot of community? Halo, basically the same with Raspberry Pi 5 support, or Jetsons, that like the default board for last 10 years. I would not use TIHAS instruments for tasks where I need to create like some mass device super cheap, because there are Saffron's boards, there are Rock Chips boards, and a lot of Chinese vendors. I would not use TIHAS instruments for any complex projects like robotics, navigation, and 3D scanning. And definitely I will not use TIHAS instruments with project where like a new neural network architecture would be involved. But it's a good board for production environment where you need like certification on temperature, certification of usage. For example, you can't use like Chinese board in US hospitals. You can't use Chinese boards like in government infrastructure. You can't like use them in military. Probably you can't use them as a part of smart cities. And when we look from this perspective, like the real good board with all certification, all regulation, and all stuff like this, actually TIHAS Instruments is quite good board. Yes, you have like competitors like Jetsons, like Intel, which will be much more expensive. You have competitors maybe like Qualcomm, which is a little bit more regulated. You need much more time to access like libraries development. On the other hand, you have like NXP, which probably is the only one competitors here, but they are like slower. They also have some Chinese regulation, Chinese like architecture inside of them. So looking from this perspective, TIHAS Instruments, it's a really like compromise platform for a lot of application. And it's not bad platform. It can work in a lot of environments. So from this perspective, this platform is definitely workable. It has a lot of interesting stuff inside, but it's not the platform that you want take as the first choice platform in situation when you don't have any restrictions. So this is my opinion. I hope you will write your opinion in the comments, and probably we will meet in the next video. Thank you for watching. Bye.